Hello. Now let us talk about plane stress transformation equations. Now, in the previous class, if let us recap what we learned in the previous class. So we are basically trying to find the stresses on an oblique plane, right? Oblique plane. So in the previous class, I have told you that we have two methods of finding stresses on an oblique plane, but from what? From perpendicular and horizontal planes. Okay, so we have two methods. First is method of equilibrium, and other is stress transformation equations. Okay, so we did the method of equilibrium earlier. So in this class we are going to talk about the equations. Okay, so the first method was a bit long. Okay, you needed to solve it. You needed to apply the equations of equilibrium about the two directions, along the two directions, right? But here you don't have to do too much things. You just have to put the things in the equation, and remember the sign convention. Okay, put the things based on the sign convention and you will get the result ASAP. Okay, so this is very fast. Okay, but you have to remember at least two equations in this. Okay, now basically what we are talking about is when you have stress with respect to one coordinate system. Okay, when you know the stress with respect to one coordinate system, it is not necessary. Okay, for example, this is x-axis and this is y-axis, but keep in mind it is not necessary they have to be one horizontal axis and another vertical axis. Okay, it is not necessary. Okay, it can be anything. Okay, for example, it can be also like this. Okay, now for example, these are the stresses here. Okay, let us say this is x prime and this is y prime. Okay, for example, it is sigma x prime. Okay, for example, this is sigma y prime. The sigma x prime and the sigma y prime, and this sigma x prime and sigma y prime is with respect to the x prime and y prime axes, right? So now if you know this thing and you want to find stresses about another axis. Okay, for example, now this is another x double prime, for example this is y double prime, and now here you want to find the stresses sigma x double prime and sigma y double prime, and you want to know this from what? From these values. Okay, so how do we find sigma y prime double prime, sigma x double prime from sigma x prime and sigma y double prime? Okay, so this is what you can either apply method of equilibrium or you can apply stress transformation equations. Okay, so keep in mind why I did this. The thing is that some people may think that it is all only when the stresses along the horizontal and the vertical, and we want to find stresses about the oblique plane, then you apply these stress transformation equation, but that's not the case. Okay, so if you want to understand it very well, and if you want to solve the advanced problems in plane stress transformation, you need to know this concept that it is irrespective of this. Okay, it doesn't have to be, it can be anything, it can be any rotation. Okay, and this thing can be any rotation. Okay, this thing can be any rotation. Okay, so what is important here is we need to know the angle theta. Okay, we need to know angle, let us call it theta, between old coordinate system and new coordinate system. Okay, now the way I am teaching you this, if you search these lectures in the YouTube or anywhere, if I'm sure you will not find much like this, because they just learn from a single book and they tell you some basic things, and then when you try to solve problems, advanced problems, you are not able to do that. Okay, so if you listen to me carefully, okay, if you listen to me carefully, I can guarantee you can solve any simple problem in plane stress transformation, and you can also solve any of the advanced or what others they feel that they are complex. Well, the same problem, it will seem simple to you. Okay, so just bear with me and learn. Okay, so you can find a stress transformation with respect to new coordinate system. Okay, but using the coordinate system, old coordinate system. Okay, but what you need to know the angle theta. Okay, what is this angle theta between old and the new? Okay, so if you know this angle, okay, if you know this angle, for example, if you know the angle between them, okay, if you know the angle, if you know it, you can find the stresses, whatever. Okay, so the angle between the two is important. Okay, so to know the angle, we keep our standard rotation. Okay, we keep and anti-clockwise rotation. Okay, we keep it as standard and it is positive. Okay, so let me show you here. If this is, for example, I will not keep it vertical. Okay, but you will see most of the books, they will keep this as vertical. Okay, I will rotate it. Okay, so this is one coordinate system. Okay, let us say this is x-axis and this is y-axis. Okay, now this is another coordinate system. Okay, I rotate it anti-clockwise. Okay, so first of all, let me first write this x and y. Okay, x prime and y prime, so that I can recognize them. Let us say it is rotated somewhere. Okay, I can keep it anywhere. For example, let us say like this. Okay, now you can see this x prime is rotated to x dash, right? X is rotated to x dash prime, right? So this is the angle theta. Since theta is the angle between x and x prime, so theta is also going to be the angle between y and y prime. Okay, this is theta. Okay, so these are the positive sides. This is the positive x-axis, right? X prime, positive x prime. This along this is positive y prime, and this one is positive x-axis, this one is positive y-axis, and the other side, these four sides, okay, they are all negative. Okay, they are all negative. Okay, and this is the reason I call this as all the four, I call it as dark side. Okay, dark side, and I call these the positive things, I call it the bright side. Okay, again, it is not in any book. Okay, it is just my wording. Okay, and keep in mind, you can learn this. It doesn't matter from which country you are. Okay, or from which university you are studying, anywhere in the world. Okay, it applies globally. Okay, now anyways, so what is important is you need to know the angle theta between the two coordinate axes, then you can find the stress. Okay, so this is what is plane stress transformation. Okay, and remember, the anti-clockwise direction is positive. It is just a standard. Okay, it is just a standard. Okay, now anyways, we did talk about this, so let us talk about these plane stress transformation equations. Okay, so let's talk about these stress transformation equations. Okay, so let me write. So stress, or basically I mean plane stress, right? Stress transformation equations. Okay, so let us talk about these. Okay, Okay, so let me just write those equations. Okay, so it is let me just draw the drawing first. So again I will rotate it. Okay, let us say this is x-axis and this is y-axis. Okay, now you rotate it further. Okay, like this. Let us say this is x prime, this is y prime. Okay, you rotate it with angle theta. Okay, okay, then what we have sigma x prime is sigma x plus sigma y by 2. Okay, sum of the stresses along one coordinate system and they are divided by 2, then the difference between 2, sigma x minus sigma y by 2, and cosine of 2 theta plus tau xy sine of 2 theta. Okay, and in the new coordinate system, okay, shear stress on the new coordinate system is like this. The first term is nothing. Okay, then we have negative sigma x minus sigma y by 2 sine of 2 theta plus tau xy sine 2 theta. Okay, so basically the same things, but instead of here it is cos, but here it is sine. Okay, and here it is sine and here it is cos. Okay, it is cosine. Okay, cosine of 2 theta. Okay, so wherever here is cosine, so at the corresponding place we have sine, but here we have a plus sign, but here we have a negative sign, and this term is 0 here. Okay, so I didn't write it. Okay, so these are our these are our equations. Okay, so we call them as stress transformation equation. Okay, now what are these? We have two sides. This is the left side and this is the right side. Okay, so the left side is what? The left side is stresses on with respect to the new, or rather I will call it as rotated. Okay, stresses on rotated coordinate system, and this is what? This is old coordinate system, right? Old coordinate system. Okay, so you found a relation between the old and the new coordinate system, and it is only possible when you know the angle between the old and the new. Okay, you know the angle is theta, and then you don't apply theta, you apply twice of theta. Okay, remember this, 2 times. Okay, 2 times angle. Okay, in the equation we have 2 times of theta, 2 times of theta. Okay, but here the actual anti-clockwise angle is only theta. Okay, now sigma x sigma y by 2. Okay, let me now add a simple example here. Let us say we have, this is x-axis and here we have this y-axis. Okay, now the corresponding I will show them with the gray color. Okay, now this is the corresponding negative x-axis and this is negative y-axis. Okay, this is sigma y, this is sigma x. Okay, now when you rotate it, okay, for example you rotate it, now you rotate it anti-clockwise. Okay, now this was x-axis. Okay, this is x-axis, now this is x prime, this is y prime. Okay, and you rotate it with angle theta. Okay, now here we have, this is here was sigma x, right, sigma x, but instead of that we have now sigma x prime, and here we have sigma y prime. Okay, so if you want to find the sigma x prime, okay, now similarly, for example, here if we had tau xy, okay, but here it is going to be tau x prime y prime. Okay, so sigma x prime is going to be sigma x plus sigma y by 2. Okay, so sum of this sigma x plus sigma y by 2, you want to find sigma x prime, plus then sigma x minus sigma y by 2 times cosine of the angle, cosine of basically 2 times the angle, plus this shear stress tau xy sine of 2 times of the angle. Okay, now if you want to find the sigma y prime, it is this first term is 0, then we have this, right, sine of 2 theta plus tau xy cosine of 2 theta. Okay, so it is how you find, okay, not sigma y, it is tau x prime y prime. Okay, I'm sorry, yes, it is tau x prime y prime. Okay, so this is how you find, if you know the old system, stresses on the old axis, you can, you know, find this stresses on the new axis. Okay, rotated right in this way. Okay, so it is this. Now the question is, you found this, you know, sigma x prime, right, tau x dash y dash, but what about this one, sigma y prime? Okay, so I will show it here. Let me erase all of this. Okay, now let us give it a clockwise, anti-clockwise rotation. Okay, now let us say this is the old coordinate system, coordinate axis. Okay, now this is our new coordinate axis. Okay, and you gave it an anti-clockwise rotation of what, for example, theta. Okay, so this is our new coordinate axis. Okay, again this green is perfectly horizontal and vertical, and as I have told you before, they don't have to be perfectly horizontal or vertical. Both of these coordinate systems can be of any rotation. What matters is, as long as you know the accurate angle between these two coordinate axes, you are good. Okay, so let us say this is, we gave it an rotation of anti-clockwise rotation of theta, so this is x prime and this is y prime, right? Why it is x prime? Because you see, you got the rotation, and this is x prime. Since this thing is the, you know, rotation of this y axis, this is the reason this is y prime. Okay, and this x prime, how do we got this? We got this when we rotate the x. Okay, so this is the reason this is x prime and not another axis. Okay, now if this is sigma x, for example, in the old coordinate system, along the x-axis is sigma x, stress, normal stress along the x-axis, right? Now this is old, let me show here. Now this is sigma y prime, right, normal stress along the y prime new axis, right? Now this one is what, this one is sigma x dash, right? This one is sigma x prime. It is what, it is, you know, normal stress along the new x-axis, right? This is the new x-axis. Now how we know, you see this sigma x-axis, you found this sigma x axis from this sigma x. Why? Because you know the angle between them. Okay, so the thing is that if you know the angle between the two axes, you can find the stress on one axis with respect to the other. Okay, now if we know the stress on this, if we know the angle between this y prime and this again x, okay, if we know this angle, right, we will be able to find the sigma y prime, right, because here we have sigma y prime, right, and here what is it? It is sigma x, right, because this is the original before rotation axis. Okay, so the thing is that if we know the angle between them, you can find the stress on this, right, because this is what this equation teaches us. Okay, you know the angle between them, and you know you found the new stresses on the old from the stresses of the old coordinate system. Okay, so this is the x-axis is the old one, right, before rotation, and this y prime is after rotation. So this is the old and this is the new axis, right, and if you know the angle between them, we will be able to find the sigma y prime. Okay, now let us find this angle. Now this angle is theta, right, so this much is theta, and how much is this? This is x prime, this is y prime, right. Now you know if this is x, this is y, this is 90 degrees, right. Again, if this is x prime, let me show it like this. So the angle between the the two is always 90 degree. Okay, this is 90 degree. Okay, so if it was like this, for example like this, again the angle between them is 90 degrees, right. So this, because this is the same axis, x dash and y dash, this is the same coordinate system, like this was same coordinate system, right, so the angle is always 90. So this much is 90, right. -90 degree. Okay, so this is theta, this is 90, and what is the total angle? The total angle is how much? The total angle is 90 plus theta. Okay, so in the angle between this x axis and the y prime axis is 90 plus theta. You know the angle between them. Now you can find the stress. Okay, stress on one axis from the stresses on the other axis, because you know the angle between them. Okay, so what you do here in this equation, so wherever there is theta, you put 90 plus theta. Okay, here also you put 90 plus theta, and you will get sigma y prime. Okay, so sigma y prime, how do we get this? We get this from by replacing theta with 90 plus theta. Okay, so initially you got sigma x prime because of theta, right. Why you got sigma x prime? This is sigma x prime. Why you got? Because of theta, because this is the angle between, theta is the angle between them. Okay, now the angle is 90 plus theta, so you get sigma y prime, right. Initially it was theta, so it is sigma x prime because the angle is sigma x prime between them, right. Now the angle is 90 plus theta, so you got sigma y prime. Okay, I hope you understand this. Now let us talk about the sign convention. Okay, so let me resolve this first. Now the sign convention. Okay, so if this is for example 1, So let us say this is x-axis, for example this is y-axis. Okay, now again the book, the books show it like perfectly like this. Okay, then they say this is perfectly horizontal and this is perfectly vertical, and I have told you before what is the problem with that. The problem is you are not able to solve the advanced problems. Okay, so anyways, let us say this is x-axis, this is y-axis. Here we have sigma x, this is sigma y. Okay, now whatever is on these sides, okay, so it is basically like this. This is x, this is y. So in the bright side, if the two arrows, or on this side whatever, if two arrows have, if an arrow have the same direction as of these, okay, in that side it is positive. Okay, so for example in this, because it is in this side, bright side, okay, positive side, they have the same direction, it is, so this vector is, this force is positive here, but the same force if I draw it here, but it is in this side, here it is negative because they are opposite. Okay, so on a basically in any coordinate, anywhere here, for example if it is like this, same arrows, okay, because it is here, so it is positive, right? But if it was like this, but it is, they are opposite, right? They are opposite, so here it is negative. Okay, similarly here they are the same side, right? So it is positive. Okay, so the thing is, if they are along the same axis, they are positive. Okay, now for example let us see this arrow is sigma x, this sigma x is positive because it is in the same direction. Okay, now for example this shear stress, okay, now this shear stress, it is here, right? This shear stress is here, it is parallel to this, so they are on the same side, it is positive. Okay, so this is positive, so this is positive. Okay, now let me show you some other. Let us say this is x-axis, this is y-axis. Okay, let us see we have a stress here of 80 megapascal, and here it is 30 megapascal. Okay, and here it is 25 megapascal. Okay, now this 30 megapascal, they have the same arrow, so it is, this 30 megapascal is positive, right? Now this 80 megapascal, the arrow is, this is towards left, and but the arrow of the coordinate axis is towards right, so it is negative. Okay, so it is minus 80 megapascal, it is sigma x, right? And this is sigma y, right? Now what is tau xy? Now if you look, I will explain the shear sign convention of shear stresses more thoroughly. Basically this is the x, positive x, this is the y. Okay, so this is the bright side. Okay, this is the bright side, so whatever the stress here is, okay, they are what, they are the primaries, and in the dark side they are just the complementary. Okay, this is the complementary, or the bright dark side, they are just because they are the complementary to whatever is here. For example, if we have a normal stress x here, so there will be an complementary stress here. Okay, but we call this as complementary. Okay, so it doesn't matter. Okay, the complementary side doesn't matter. So similarly the shear stress here or here, this is on the bright side. Okay, so this is the primary. Okay, and here, because it is up, here it is going to be the complementary, down it is towards the right, here it is going to be towards left, opposite of this. Okay, but these two are complementary. Okay, so these two, because they are the primary stresses, right? So they will be, the sign convention will be decided by these two axes. Okay, so here it is the same direction, because this is a vertical arrow, so we we judge it with the help of the vertical coordinate axis, right? Because we judge a camel with the help of a camel. Okay, we don't judge a camel by a fish. Okay, we judge a camel by a camel. Okay, Now this horizontal complementary stress, it is parallel to the horizontal, so we compare it with the parallel coordinate axis, so it is on the same side, right, same side, so it is positive. Okay, so if here it was, for example, 25 megapascal like this, okay, because it is on the same side. Okay, if you don't compare this, you can also compare this, you can just compare any one of these. Okay, so it is tau xy, it is positive, right? So this is the sign convention of the old axis, right? Because we are talking about the old coordinate system. Okay, we didn't see the sign convention in the rotated coordinate axis. Okay, so let us see about the rotated coordinate axis. Okay, now if we rotate it, for example, let me show you here. This is rotated, right? So this is rotated y-axis, rotated x-axis. Why? Because here it was x-axis, right? This was x-axis, you rotated, and this was y-axis, right? And you rotate it, right? You got this. Okay, because this was y-axis, and this is the reason this one is y prime. Okay, because it is because of the rotation of y-axis. Okay, now why is this x-axis x prime, why it is not y prime? It is because we got this from the rotation of the x-axis. Okay, anyways, now the stresses here, again the rule will follow the same. If it is along the the arrows, if the arrows are same along the same, they are positive. Okay, now the bright side. Okay, now the stresses, again the stresses will be these two, right? And these two are complementary, they don't matter. Okay, now here if it is like this, so we compare it with this. Okay, so this is the same sign, same direction, so here it is going to be positive. Okay, but if it was like, for example, if it was like this, okay, then we compare it this with parallel axis, right? Here it is up, but here it is down, so this would have been negative. Okay, is there anything, did I miss anything? Now yes, one more thing, what if you have only complementary stresses? Okay, what if you have only complementary stresses, what you would do? Now here in the case of complementary stresses, let me draw it first. Now in the complementary side is opposite. Okay, for example, here it was, for example, let us take this one. Let me first draw, I think we need something clear. Okay, let us draw something clear. And the way I am teaching you, keep in mind that you are going to be master in this plane stress transformation. Okay, so you are not learning some basic. Okay, keep in mind you are learning advanced tips that I am teaching you, so that you can solve any of the problem. Now let us say this is x prime, this is y prime. Okay, now let me draw the the box too. Now let us say this is y prime and this is x prime. Now if a stress is like this is sigma x prime. Okay, but we were talking about the complementary ones. Okay, because we already know about the normal stresses. Now if we have, for example, stress here, okay, now the complementary of this, it is towards right, so this is will be towards left, this is towards, this is upward, so the complementary will be downward. Okay, now this is along this. Okay, so this is along this, so they are positive. Okay, so we are in the positive. Okay, now if you see the complementary, Complementary will be positive if they are opposite. Okay, for example, it is like this, opposite to this, right? So it is positive. Why positive? Because we are comparing the complementary. Okay, because otherwise the rule is what? The rule is simply if it is along, I mean the same direction, in the bright side, then it is positive, but in the complementary side, if they are opposite, then they are positive. Okay, so this and this, they are opposite, so it is positive. Okay, so we have in the bright side, so I hope you know what is bright side. Okay, so this thing, this side, it is bright side. Okay, and because this is the positive direction, right? Positive x-axis and positive y-axis. Okay, or I will call it as positive side. Okay, positive side. Okay, so if in the positive side, same direction mean is positive. Okay, but if you are comparing a force from the negative side, okay, force from the negative side, force in negative side, then what is the rule? The rule is opposite. If it is opposite, then it is positive. Okay, so I hope you understand the sign convention. So let us solve the problem now. Okay, now we have this problem here. Now let us draw the axis first. So this is the positive x-axis and this is the positive y-axis, and now this 50 megapascal, it is along the y-axis. It means it is a normal stress along the y-axis, but is it positive or negative? The arrow is in the same direction, right? So it is positive. So we got sigma y is 50 megapascal. Then this 80 megapascal, it is parallel to the x-axis, and it is, the arrow is, this is towards left and it is towards right, so it is negative. Sigma x is, first I will write sigma x. Why? Because in the equations first is sigma x, then is sigma y. Okay, so it is minus 80 megapascal. Now tau xy, you can see this arrow, it is opposite to this, right? So it is negative, right? Tau xy is minus 25. Now what do we have to do? Find stresses on oblique plane inclined by 30-degree clockwise using stress transformation equations. Okay, so we have to use those equations. Okay, but 30-degree clockwise, it is anti-clockwise angle is positive and clockwise is negative. Okay, negative 30 degrees, right? Because the anti-clockwise is positive. Okay, so what is we have to find on this? Okay, so on this plane, let us say we will have some plane, right, on 30 degrees. Okay, so if we rotate 30 degrees, for example, I mean this diagram is not important to draw, but I am just explaining it. Okay, so it is saying plane inclined by 30-degree clockwise. Okay, so we will rotate by 30 degrees like this. Okay, so let us say this is 30-degree clockwise rotation. Okay, okay, so this is going to be x dash. Okay, it is going to be y prime or y dash. Okay, so the body is going to be something like, rotated body is going to be something like this. Okay, and then we will have sigma x prime on the rotated. We will also have maybe sigma y prime, we don't know, maybe it is 0, but we have to calculate. We will also have stresses on these. Basically we will have everything on this. This is 30-degree clockwise. We are going to have everything. Okay, sigma x, this is going to be sigma y. Okay, and maybe we will have tau x prime y prime 2. Okay, so what is the value of sigma x prime? So let me erase all of this first. Sigma x prime is sigma x plus sigma y by 2 plus sigma x minus sigma y by 2 cosine of 2 times of the theta plus tau xy sine 2 theta, and we have, when we want to find sigma y prime, what we have to do, we have to replace theta with 90 degree plus theta, and then we have tau x prime y prime. It is going to be, the first term is 0, okay, then we have negative of negative, here it is positive, but here it is negative sigma x minus sigma y by 2. Here it is sine, but we will have here cosine, but we will have here sine plus tau xy. Here it is sine, but we will have cosine 2 theta. Okay, so let me use a calculator to find the values. Okay, you can also try, because here are the correct answers. Okay, and let us see if you get the correct answers. So it is sigma x plus sigma y by 2, it is minus 80 plus 50 divided by 2 plus minus 80 minus 50 divided by 2 times cosine of minus 2 times 30, right? 2 times 30 is 60, so it is minus 60 plus minus 25 sine of minus 60. Okay, so we got minus 25.85. okay, so minus 25.85, so our answer is correct. Okay, so later I will tell you what does this negative mean. Okay, so let me first find all the values, then I will tell you what this negative means. Okay, now sigma y prime, we have to replace theta with 90 plus theta on the cos side. Similarly, on the sine side, I have to replace theta with 90 plus theta. Okay, so I got sigma y to be minus 4.15. okay, megapascal. Okay, again our sigma y is correct. Then let us find the shear stress on the rotated axis. Negative minus 80 minus 50 divided by 2 sine of minus 60 minus 25 cosine of minus 60. So it is minus 68.79. okay, which is minus 68.8 megapascal, which is right. Okay, 8 megapascal. Okay, so we got the correct answer. Okay, now let us see what do I mean this by this. Okay, negative means it is opposite. So if we draw some I will show you this rotated. So this is x, positive x, and this is positive y, right? Now what you did, you rotated it, right? You rotated with clockwise, right? So you got like this. Okay, you got something like this. Okay, basically this is the angle 30 degrees, right? Now sigma x prime is minus 25.8 megapascal. Okay, so here it's supposed to be, this is x prime, this is y prime, right? So sigma x prime is supposed to be here, but since it is negative, it is going to be opposite. Okay, it is going to be like this. Okay, so it is minus 25.8. okay, so it is 25.8 megapascal. Okay, and this one is the complementary. Okay, you can draw it and or you cannot draw, it is your choice. Okay, but I will draw the complementary too. So this is sigma x prime. Now let us talk about sigma y prime. Minus 4.15, again negative means opposite, right? So y prime, if I draw like this, same arrow, it is going to be positive, but we have negative. Negative means opposite. Minus, how much is it? 4.15 megapascal. Okay, now you don't have to write the negative again because you already show it with the help of arrow. Okay, so you don't have to write the negative again. Okay, so here it is the complementary. Okay, complementary is the opposite. Okay, now shear stress is minus 68.8. okay, now negative. Okay, so if I draw, we can draw here or here. Okay, because these are the primary. So if I draw here, but it is negative. Okay, so this side it is positive, right, because the arrow is towards left. So I will draw like this. Okay, it is why, because this arrow and this arrow, they are opposite, and opposite means negative. Okay, so it is, how much is it? 68.8. okay, 68.8 megapascal. Okay, this is 68.8 megapascal. Okay, now it is this. This is 68.8 megapascal. Okay, so I hope you understand everything. If you have any doubts, you can comment. Okay, and this is your homework problem. Okay, so try this, and in the next class you can I will provide the solution of this. Okay, so that's it for this class. See you in the next class. Thank you.